now officially recording. Welcome to all of you to our webinar. And if you can, let us know who you are. And we can see that, I guess, with your name in the chat. But what brings you here and what is your role at your office or school? Okay, and this is a learning event, so we're not going to just blah, blah, blah talk. Hopefully you'll walk away with something new that you learned about computer science, or something you can do with your class or your teachers, something you can take away with you tomorrow that you can use. Okay, so next slide. You can't see the slides.
Sorry.
But all of you have access to the slides in the agenda, which I will type into the chat. Okay.
Sorry about that.
There we go. And so here's a Bellringer activity that we would start with if we had people waiting around, or you can do this with your class. And just to kind of get you to think about the 5 core concepts of computer science. And you're going, what are the 5 core concepts? Well, we will hopefully you'll learn more about that in our webinar today, our learning event. And so there are some terms below, and we want you to think about where do some of these terms go under computing systems, algorithms and programming, networks and the internet, data analysis, and impacts of computing. Those are the 5 core concepts in computer science. And so I kind of helped you out a little, like big data, of course, goes under data, but it might go in other places too. And coding, everything's computer science. Coding, well, that goes under algorithms and programming. And so here are some other terms that we'll be talking about throughout this year. So hopefully you'll join us at other learning events. And by the end, you should know what all of these terms mean. Okay, so we're not going to do this activity because we're very short on time, but by the end of the year, you should be able to categorize everything and know what the 5 core concepts are. And there's no one right answer either. Okay, some of these go under different categories. Next slide. So I'll turn it over to Faith.
Okay, thanks, Janine. As Janine was mentioning, when we hear computer science, many people think about writing code or programming, but as we saw in that Bellringer activity just now, there are actually 5 core concepts to computer science. So as Janine mentioned, at our monthly learning events, we'll go a little deeper into each of the core concepts. But today, being our first session, will be an overview. So let's watch this overview video. And as you're watching, listen for something that you may not have known before.
Computer science, computers, coding, programming. It's this and much more.
If you gotta switch the tab.
Let's go back to the draw.
Oh, rats. Oh, it disappeared.
There you go.
Thank you. Sorry.
What do you think about when you hear the words computer science? Computers, coding, programming? It's this and much more. Let's go back to the drawing board and look at the K12.
Wait, we're getting an echo.
One day when I was actually painting houses and driving a lot, I'm sitting on my wallet at lunchtime. It was just the most uncomfortable thing.
Getting an echo.
Faith, I'll present it.
Thank you. I don't know what happened to the video. I'm sorry.
Think about when you hear the words computer science.
You guys hearing that? Okay.
Computers, coding, programming. It's this and much more. Let's go back to the drawing board and look at the K12 Computer Science Framework. This framework organizes computer science into 5 core concepts representing key content areas. The first core concept is computing systems, which includes devices, hardware and software, and troubleshooting. People interact with a wide variety of computing devices that collect, store, analyze, and act upon information. A computing system is made up of hardware and software and communicates and processes information in a digital form. An understanding of hardware and software is useful when troubleshooting a computing system that does not work as intended. The second core concept, Networks and the Internet deals with network communication and cybersecurity. Computing devices typically do not operate in isolation. Networks connect computing devices to share information and resources. Cybersecurity deals with transmitting information securely across networks. The third core concept, data and analysis, involves storage, collection, visualization and transformation, and inference and models. Computing systems exist to process data effectively. Data is collected and stored so that it can be analyzed to better understand the world. The fourth core concept, algorithms and programming, includes algorithms, variables, control, modularity, and program development. An algorithm is a sequence of steps designed to accomplish a specific task. Algorithms are translated into programs or code to provide instructions for computing devices. And the last core concept is impacts of computing, which includes culture, social interactions, and safety, law, and ethics. Practicing good digital citizenship empowers our students to make safe, smart, and ethical decisions. So the next time you hear computer science, remember the 5 core concepts from the K12 Computer Science Framework. Let's teach our students to be computationally literate and proficient in the concepts of computer science for the 21st century and beyond.
Thank you, Charles. So we hope that video gave you a better idea of what computer science encompasses. And we do want our students to be aware of these 5 core concepts so they can make informed decisions and participate safely and responsibly in our digital world. So on this slide, we included a few links for your convenience. So there's the Computer Science Teachers Association, CSTA, K12 Computer Science Standards that was adopted in Hawaii in 2018. And these standards can be filtered by concept and grade level. Also the CSTA K12 Standards Progression Chart to give you an idea of the grade level band before and after yours in addition to your own. And the CSTA Standards, Computer Science Standards for Teachers. And the video can be found on our Computer Science HIDOE page. So as we learn about computer science, you may hear the name Ada Lovelace. Who was she and why is she known as the first computer programmer? So we're going to share some information from 2 books. One is Ada Lovelace, First Computer Programmer by Amy Hayes. And the second book is Who Said Women Can't Be Computer Programmers? A Story of Ada Lovelace by Tanya Lee Stone. Ada Lovelace was born Augusta Ada Gordon. She was the daughter of George Gordon Byron, commonly known as Lord Byron. Her father, Lord Byron, was one of the first celebrities. He was brilliant, emotional, and wrote beautiful poems that are still read today. Her mother, Anne Isabel, was strict, religious, and very focused on academics. Lady Byron wanted to make sure Ada would be ruled by logic and not emotion. So she took Ada and separated from Lord Byron when Ada was 1 month old. Lady Byron disapproved of Ada playing imagination games. She decided she would fill Ada's head with math. So by the time Ada was 5, she was learning basic geometry and could add together sums of 5 or 6 different numbers. Ada's mother hired the best tutor she could find for her daughter. When Ada was 17, she came out to society. She met many interesting people. One person, Charles Babbage, was working on a machine that performed like a calculator. Ada had the opportunity to see the machine. She was so fascinated. She examined the gears, rods, and wheels and figured out how it worked. In 1834, Babbage shifted his focus to a new machine called the analytic engine that went beyond just calculating numbers and functioned based on instructions. So Babbage had seen a jacquard weaving loom that used cards with specially placed holes, and each card told the loom what color thread or design to weave. And this loom could weave complicated patterns that looked like paintings. Ada understood how the machine works, and she understood mathematics. And together with her imagination, the analytic engine could adapt the punch card system to follow algorithms of unlimited instruction that today we call computer software. And for that reason, Ada is known as the first computer programmer. In 1834, Ada married William King, who became Earl of Lovelace, and she became Augusta Ada King, Countess of Lovelace, or Lady Lovelace. The name Ada Lovelace is not really accurate, but it's the name that has stuck over time. Sadly, Ada Lovelace passed away shortly before her 37th birthday, but her discoveries have lasted so many lifetimes. So these two books were borrowed from our statewide ebook collection. And to access and enjoy these and other ebooks and audiobooks, visit soraapp.com. And if it's your first visit, click on a green button that says My School is Hawaii State Department of Education. Enter your 8-digit employee number, and students can access the library collection by entering their 10-digit student ID number. In addition to accessing the full library at soraapp.com, the computer science team has curated a computer science bookshelf of ebooks and audiobooks that can be found on our internal CS support site at hidoe-cs. There are currently about 100 curated computer science related titles there. And here's a punch card activity. On the left are the ASCII binary numbers that represent the letters of the alphabet. And on the right are the same binary alphabets converted into punch cards. So if you click on the link that's on this slide, you can download the activity for $1 and learn and cut out the letters, create a bracelet or a folder. I created this little name bracelet, and I have a little folder with Janine's name on it, hard to see. It's kind of fun activities for students. I'll mention that the ASCII binary alphabet chart on the left shows 7 digits, and the punch card system on the right shows 8 digits. So you actually have to put a 0 in front of the ASCII numbers to make an exact corresponding pattern. And this is a nice activity to introduce to students and to talk about binary numbers and computers. Today, let's decode these 5 letters. What do they spell? Can you please type your answer in the chat? We'll give you a few minutes to do it.
I feel like we should have music like da 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 da. And by the way, while folks are working, just as a reminder, we have the agenda in the chat. Oh, we have an answer. And all of our links are in the agenda. And I will also put the recording link in there once we get it processed. So everything is one-stop shop in the agenda.
So Carrie has put in an answer. I don't know if anybody else, if you agree or think it's might be something else. All right, John. So looks like we got a lot of Byrons. And if your name is alphabetically close to Byron, which is the correct answer, then we have something for you. And turn it over to Charles to talk about our prizes. Oops, what happened?
Yeah, so we're just gonna do a quick check for you guys to look through the attendee list and see if your name is the closest. If your name is the closest to Byron, go ahead and put it in the chat. If you think that you won this part of the competition, you can put it in. If you enter correctly, you will get a prize, and we'll send that to you through Armor Card. We'll send it directly to your school. You'll get it. These are some of the prizes that we've collected from different events. So if your name is closest, you can put it in. If you think your name is the closest and you incorrectly enter, then maybe you owe us a prize. I don't know. So so go fast, but go be correct. So we should have started with prizes. Yeah. Keep that in mind for the afternoon session. Come back for that. If you don't win this one, you can come back for the afternoon session and try again. Maybe your name will be closer then. We have any answers yet? No.
Just your first name too.
Oh.
Yeah, Carrie. You do have a very long name. Just your first. You're actually Carrie is pretty close. Are you the closest to Byron alphabetically?
Oh, she put in.
Ooh.
She's committing her name. Let's see.
And
Check
by the way,
everybody else confirm. That's.
I just want to add that this is a computer science concept. It's kind of like a bubble sort where you're comparing things to see which is the closest or in the parameter that you want. So you kind of have to do some bubble sorting in your head to figure out if your name is closest to Byron alphabetically.
All right.
Oh,
Carrie,
Carrie.
Yep, that was brave. She put it out. Looks
Okay.
like there's not any other C's or B's. So
I will record that name down and then I will track you down and send you a prize.
Is it random, Janine? That's the prize?
Yeah. Although, since Carrie is the first one, did she get Byron also? Was she the
Yes,
first one?
I did. I was the first one.
Wow. You can choose. You can tell me right now what you want if you can do it in like 5 seconds. And otherwise, I'll randomly just send you something.
You can send me earbuds. I always need those.
All right.
Yeah,
Thank
good
you so
choice.
much.
Awesome. Carrie is on fire.
All right.
Thanks for playing the game with us. And so we also wanted to share with you, there are recent legislative updates and related to computer science. So if we can watch this short video and see where the computer science team for Hawaii Department of Education has been and what's ahead of us in terms of computer science in the coming 3 years or so. So please watch the video.
Computer science provides a platform for fun, relevant, and engaging learning. As a state, we have taken several steps to infuse computer science into all K-12 schools statewide. Let's take a look at where we started and where we're headed with computer science in Hawaii. In 2017, the Hawaii State Department of Education formed a computer science work group to convene a community of internal and external partners to explore how pre-K through 12 students can have computer science learning opportunities in school and beyond. The work group incorporated feedback from educators and stakeholders into a state action plan for computer science education to ensure that computer science learning and opportunities were provided with equity and access for all students. On May 3, 2018, the Hawaii State Board of Education approved the adoption of computer science standards based on the K12 Computer Science Framework. On June 21, 2018, Governor David Ige signed into law Act 51 to develop and implement a statewide computer science curricula plan and ensure each public high school offers at least one computer science course by school year 2021 to 2022. On November 14, 2019, a Department of Education memo shared system updates that would take effect during school year 2020 to 2021. Equivalencies were identified to allow teachers to be Hawaii qualified in computer science. Computer science replaced the educational technology category in Infinite Campus. In addition, computer science was added as a content option for the additional content area section of the elementary report card. Advanced placement computer science courses categorized under multidisciplinary were changed to computer science. On July 1st, 2021, Act 158 was signed into law by Governor Ige and requires the Department of Education to address the following. 1. Beginning with the 2022 to 2023 school year, at least one public elementary and middle intermediate school in each complex area shall offer computer science courses or content. 2. Beginning with the 2023 to 2024 school year, no less than 50% of the public elementary and middle intermediate schools in each complex area shall offer computer science courses or content. And 3. Beginning with the 2024 to 2025 school year, all public elementary and middle intermediate schools shall offer computer science courses or content. By June 30th, 2022, and each June 30th thereafter, the superintendent shall submit to the Board of Education and Legislature a report of the computer science courses and content offered during the previous school year in each complex area. As we look back at the accomplishments that have been made, we are encouraged in continuing our journey to provide all students with equitable and accessible computer science opportunities.
Thank you, Charles. So as you saw from the video, there are exciting times ahead of us. We're really happy for our students who will have more computer science learning opportunities to prepare them for our world today and their future. And we have a form for feedback that we would ask you to complete and let us know how you enjoyed the session and how we might make it even more helpful to you. And also, we wanted to open up for questions. We'll give you a couple minutes just to fill out the form, because I know once you leave this session, it might be hard to come back to it.
I have a
All right,
quick
Norma
question.
has a question.
Oh,
Yes. I know I'm familiar with code.org as far as curriculum with coding and the coding framework. Do you or are you aware of any upcoming maybe curriculum that's being written, or are we going to be adopting any curriculum for the other core concepts, or is it like a total package thing? I've been doing a lot of research and it's having trouble finding curriculum.
yeah, you're right. Core.org has a pretty comprehensive curriculum that is K-12 and covers the standards in the 5 core concepts. And we're interesting, you should ask, because the computer science team, which is made up of representation from each complex area, there's a lead and some members from school level, have developed this guideline to help us evaluate other opportunities that may come our way. And so we haven't really, established like, here's a short list of, curriculum that we would recommend. But if you reach out to your computer science lead, they could share that guideline with you. And we, as a team, we're meeting constantly to go deeper and deeper into it, and hopefully at some point have something that's a little easier for schools to just pick from.
Faith,
But-
how would they find out who their lead is for their complex area?
Okay, so on our site, I think, okay, hold on, let me.
I'm on the site.
Oh, okay. So on the site, there are contacts in the top menu bar. And if you scroll down, you can find your complex area and the lead and their email address. So you can reach out to them and explain, where you are and what you're hoping to, establish for maybe your school or your class, and can work together.
Thank you, Faith. I have one more question.
Yes.
I'm just curious. There's a picture on slide 23. You're holding a computer kit.
Oh, yes.
What is that?
Okay, it's a Piper kit, and
Okay.
it's a fun little kit that your students can build their own computer. It has all the pieces necessary. It comes with a blueprint, and so they follow the blueprint like building a house, and
Okay.
then it runs off of Raspberry Pi.
We
So
did an event and Faith had us build it, so it's appropriate for third graders.
Third and up, you think?
Oh,
it's a joke.
Yeah, our team.
It's a joke, but probably around there, I would say.
Our team participated in actually building it. Yes, it was fun, and
How fun is that?
yeah,
Okay.
helps the students to see what goes into the computer. So yeah.
Thank you.
Thanks for the questions.
Hey, by the way, we'd really appreciate your feedback because we're planning the next event, and we're kind of looking at this one to give us feedback so that we can make the next one better. So our feedback form is really short. If you could fill it out right now before you go, because we know that once we leave these webinars that, we get busy and don't have time. So if you have feedback, please fill out our really quick and easy form. And we really do appreciate you for taking time out of your busy schedule today to join us, because we thought this year would be a little better, but apparently it's just as crazy. So.
And in the last minute or so, I'll just echo what Janine said, and really thank you guys for your participation, attendance and participation. And we hope this session gave you a better idea of those 5 core concepts of computer science, and where to find the standards and the progression charts, how to access our statewide ebook collection that I'm sure you and your students will enjoy, and we hope you had fun. So on behalf of Charles, Janine, and computer science team, thanks so much for being with us. Mahalo. Have a great day and an awesome week. Congratulations, Carrie.
She's at Wailua Elementary. So
Thank you.
Hey, Carrie, this is Janine.
Yes.
Since actually I have prize, is there anything else in that list of prizes that you'd like? Because I was going to give a giveaway 2 at each session, and since you got Byron and you close this, I can just mail 2 things. It's easy for me. Anything else you want on there?
You can pick whatever. Thank you. That's really sweet.
Okay. I will randomly choose something.
That was fun. Thank you.
Thank you for participating.
I love interactive participation. It helps me remember things.
Thank you. That's good feedback.
Yes, thank you. I'll put it down.
Okay. Faith and Janine, I'll check back with you guys. I have a 9:30. Now I gotta go.
Thanks, Charles.
Thank you so much.
Yeah, go practice some more so you can get it right at 3 o'clock.
Hey, Janine.
Yeah.
I'm wondering if it's easier if you showed the video.
Oh, wait, let me stop the recording. Hang on.
Oh, thank you. Rather than me going through all